Hello and welcome to another session in mathematics. In this session, we'll be looking at differentiation. But before that, let us take a review of our previous lesson. Welcome back. In today's lesson, we'll be looking at the product rule of differentiation, otherwise known as the multiplication of differentiation, multiplication. Okay, so when we hear about product, we're referring to what? Multiplication. So we are looking at the product rule of differentiation. So let us start. The product rule is used whenever let's say y is equal to u times v. Okay, where u and v are what? Are not constants. Where u and v are not what? Constants. They are not constants. So we use this product rule that we're about to use now, that we're about to derive now. We use it when two variables are multiplying what? Each other. Assuming we are giving y to be equal to u v, it means what? U times what? V. So we have to differentiate this with respect to what? To x. We have to differentiate this with respect to what? To x. So if we start, therefore we have y plus dy to be equal to what? U plus du, where du is what? The change in what? In u, into v plus dv, and v is the change in what? In v. Okay, so let us now start. Y plus dy will then be equal to, we open this bracket, u times v will give us what? uv. U times dv will give us what? U dv. We have the u here times v, which will give us what? V du. Du times dv will give us du dv. Right? Okay. Then step 2, we subtract what? Y from both sides. Therefore, we have y plus dy minus y, which is equal to uv plus u dv plus v du plus du dv minus, what's the value of y? The value of y is what? Uv. So this uv will cancel this uv here, and y will cancel y. We then have dy equal to u dv plus v du plus du dv. Okay, we divide through by what? Dx. Okay, now dividing through by dx, this is what we have. Okay, let's go over to this part of the screen. So we say du dv tends to 0, and if that is the case, then we have dy over dx to be equal to u dv over dx plus v du over dx plus 0 over what? Dx. So our dy over dx is equal to u dv over dx plus v du over dx, and that's the answer. Then this formula is what we call what? The product rule. Product rule states that dy over dx is equal to u dv over dx plus v du over dx. Okay, so just have it in mind. Okay, let's take some examples involving multiplication, and that's when we'll use this rule. So example number 1, if y is given to be equal to 2x minus 1 into 3x squared plus 2, find dy over dx. This is very simple to solve. Okay, right? Y is equal to 2x minus 1 into 3x squared plus 2. Remember, this is a multiplication. So we start by saying let u be the first bracket. The first bracket is 2x minus 1, and v be the second bracket, which is 3x squared plus 2. If we differentiate u with respect to x, we have du over dx. That means we should differentiate towards this. If we differentiate to x, what do we have? Remember, n x raised to the power n minus 1. What's the power of x there? 1. 1 times 2 will give us 2. Bring down your x, then subtract 1 from it. So 1 minus 1 is 0. X raised to the power 0 is equal to what? 1. 2 times 1 is 2. So we have this. And the differential, or the derivative of this constant here is what? Is 0. So du over dx is 2. Then we have dv over dx, which is the differential of or the derivative of what? This. And that will give us 6x, where this is also what? 0. Now dy over dx is given to be u dv over dx plus v du over dx. We've gotten all these values. Our u, which is the first thing, our u is 2x minus 1 times dv over dx. What's our dv over dx? dv over dx is what? Is 6x. Then plus our v, which is 3x squared plus 2 times what? Our du over dx, which is 2. Right? Opening this bracket, we have 2x times 6x, which will give us 12x squared. We'll have minus 1 times 6x to give us minus 6x. 3x squared times 2 will give us 6x squared. 2 times 2 will give us 4. So we collect like terms. 12x squared plus 6x squared will give us 18x squared minus 6x plus 4. Is there anything common here? Yeah, 2 can go into all of this. So we have 2. 2 into 18 will give us 9x squared. 2 into 6 will give us minus 3x. 2 into 4 will give us what? 2. And that is just the final answer. 2 into 9x squared minus 3x plus 2. That's the final answer. Example number 2. Assuming we are given the value of y to be equal to exponent e times sine x. To find dy over dx, the first thing we need to do is to say let u be equal to exponent x and our v be equal to sine x. Then du over dx is equal to what? Exponent x. I gave us that in our last class when we talked about the standard derivatives. I told us that when we differentiate exponent x, it's still exponent x. Then dv over dx, that is differentiating v with respect to what? To x. If we differentiate sine x, we have what? Cos x. Is that right? So let us now find our dy over dx. Our dy over dx would then be equal to, remember, it's u dv over dx plus v du over dx. So therefore dy over dx will be equal to, what's our u? Exponent x. What's our dv over dx? Cos x. Cos x. Plus, what's our v? Our v is sine x. And what's our du over dx? Exponent x. Okay, we multiply through, we have dy over dx to be equal to exponent x times cos x will give us exponent x cos x, plus sine x times exponent x is exponent x sine x. So from this, is anything common? Yeah, exponent x is common. So we bring it out. We have exponent x into cos x plus sine x, and that is just the answer. You see, so the product rule is as simple as ABCD. So we'll stop here today. Thank you for joining us in today's class. To refresh your memory on what we've done so far, kindly provide the answer to the following questions on the screen. Welcome back. So far we've been able to deal with the product rule of differentiation, and we'll stop here. So do well to use the lesson note on the platform for better information on what we've just done, and feel free to leave your comment or questions on the comment section. Till we meet again, stay safe and bye.